Lesson 13, Implicit Differentiation. We're going to differentiate this relation, x squared plus y squared equals 1. In fact, that's the equation of a circle with the center origin and the radius 1. And when we differentiate it, that will find for us slopes of tangents of this circle. So we're going to differentiate with respect to both sides. So I have d dx of x squared plus y squared equals the derivative of 1. Now, then we'll split this up, and that'll be the derivative of x squared plus the derivative of, and I write this as y all squared equals. Now, the derivative of 1 is just 0. The derivative of x squared with respect to x is 2x. Now here, we'll treat this as a function. So if I differentiate this function, the 2 will come down, and we'll reduce it by 1, and we differentiate what's inside the brackets, which is just dy dx. And that's equal to 0. Now, we can cancel the 2's, divide through by 2, we get x plus y dy dx equals 0. And take the x across the other side, and we get that's minus x. Then divide both sides by y, and we get dy dx is equal to minus x on y. Now we could actually go back and work out what y is, but it's quite okay to leave it in that particular form. For example, if we want to find the gradient of a tangent at a particular point on the curve, we simply substitute x and y into that, and that will give the gradient function at that particular point. Right, in number 2, we have to differentiate x squared plus xy plus y squared equals 1. It's a more complex relationship to differentiate. Do the same thing, we'll differentiate with respect to x to both sides. We get d dx of x squared plus d dx of xy plus d dx of y squared. Or actually, what I'll write that, I'll do this and write that as all squared equals d dx of 1. d dx of x squared with respect to x is just 2x plus, and this is the product. So this is like, let's take a different color here. This is like having a different color. That's like a U, and that's my V in here, right? So now, let's go back to it. Now if we holding the U constant and differentiating this, so this will be x, this will be dy dx plus, now holding the y constant, that'll be y, and we differentiate with respect to x of x, just 1 times 1. And as before, this will be 2y dy dx, and that's equal to 0. Now putting all the dy dx's together, we'll have x plus 2y bracket dy dx equals, and we'll take this across the other side, it's minus 2x plus y. And then finally dividing both sides by x plus 2y, we get minus 2x plus y over x plus 2y as our final result.